Hey again, method students. In this video, we're going to go through a few more examples involving continuous random variables. So let's keep pushing through. This one's actually from a past exam 1. This one says the continuous random variable x has a distribution with a probability density function given by f of x equals, and we've got just a new function, again with this sort of hybrid function notation, where we have a rule for one part of the function, where it's defined for x is greater than or equal to 0 and less than or equal to 5. And then the rest of the function is actually just defined as 0, or y equals 0. And you'll notice when you look at this rule that the function rule is ax times 5 minus x. So we've got this unknown a that we have to find the value of. Now, remember, the big idea here is that if this function is representing a probability, then the area under the function from, well, the formula sort of says it as negative infinity to infinity of f of x. So in other words, the integral of the function from negative infinity to infinity has to equal 1, okay, because it's like the total area under the function needs to be the total proportion of the whole distribution, or it's like saying that all the probabilities added together have to make 1 or 100%. But in practice, remember that these aren't the terminals we're going to use. We're just going to integrate over the values for which the function is defined. And in this case, that's going to be from 0 to 5. So we can say that the integral from 0 to 5 of the function ax times 5 minus x with respect to x has to equal 1. Okay. Now, if a is a constant, remember that we can take this constant out the front of the integral, and we can say, well, let's take a out the front and be left with integral from 0 to 5 of x times 5 minus x. Now, I'm going to do sort of two things in one go here. I'm also going to just expand these brackets because that's going to be a bit easier since we're working without a calculator for us to integrate. We can sort of just work it out term by term. Okay, and remember that it also equals 1. So taking the working up here, we can say, well, a times, now the antiderivative of 5x is going to be 5x squared over 2. Minus the antiderivative of x squared, so x cubed over 3, with the terminals of 5 and 0. Right, all of that equals 1. Okay, so subbing in our terminals now, we get a, still got a in front, but we've got a times, double bracket it. Okay, so 5x squared, so when we sub in 5, we're going to get 5 times 5 squared, or 5 times 5 squared is actually 5 times 25. So we're going to get 125 over 2. Minus, subbing in 5 in place of x here, this is x cubed, so 5 cubed is 5 times 5 times 5, that's 125 over 3. Right, so that's subbing in our upper terminal. Subbing in our lower terminal of 0, well, both of these terms will become 0. Right, all of it's still multiplied by a, which is why I put the double brackets there, and the whole equation, or the whole expression, still equals 1. All right, so now our job is just to work with this. So a times, now let's fix this up a little bit. We can put both of these fractions over 6. So if we did that, if we make this first fraction over 6, what does it need to be? We need to multiply by 3, so that'll be 375 minus the second fraction. It's going to have to multiply top and bottom by 2, so that's 250 over 6 equals 1. So a times 125 over 6 equals 1. If we times both sides by 6, we get 125a equals 6, and therefore a equals 6 over 125. And so, with a fair bit of working there, a few steps to that, we've managed to work out that a is equal to 6 over 125. But remember that this idea came from starting with the fact that we know the whole definition of a continuous, a probability density function. Sorry, the whole definition of it is that the total area under the curve has to equal 1. Okay, because it's representing a probability. Express probability that x is less than 3 as a definite integral, but do not evaluate this definite integral. Okay, so that just means we know that if we're trying to find the probability that x is less than 3, well, that means that our upper terminal is going to be 3. And in theory, our lower terminal is like negative infinity, but remember that the actual parts of the function that are giving us any area are just between x is 0 and x is 5. So we're actually going to make the lower terminal 0 here. And then we just have to write the function. And the function is ax times 5 minus x, but we now know that a is 6 over 125. So it would be 6 over 125 x times 5 minus x with respect to x. So don't forget your dx at the end of the integral. And that would be the expression that would give us the probability, but remember it said don't evaluate it, so we didn't have to. All right. Another one to have a go at here at the top of this page, we've just got a reminder of how we work out our probabilities. We just practiced it then actually, so we shouldn't need to see it again, but there it is. So in this case, another continuous random variable x with a probability density function given by f of x equals k sine x. So you can see we've got this similar to the previous question, we've got this unknown in front of the function. And the first thing we have to do is find the value of that unknown. Now, if you've just had a look through the previous example, you might actually want to pause this and have a go at it yourself, because it's a really similar kind of question. So what we're really going to say is that to find this value of k, we'll use the fact that the antiderivative, or the integral over the values for which this function is defined, which is 0 to pi of k sine x with respect to x, all of that has to equal 1. Right, and so that's the equation that we can then use to sort of solve for k. So we can pull this k out the front, because k is just a constant here. Or k is just a value, I should say. Equals 1. Apologies, I haven't really left much space on these notes, which you're probably finding annoying too. I'm trying to write big enough that you can see it clearly on the video, but sort of still fit it in. We'll see how we go. So k sitting in front. Now we're going to anti-differentiate sine x. Remember that the antiderivative of sine x is negative cos x. From 0 to pi, our terminals equals 1. So, exact values bobbing up again. So if you need to practice these, then practice them, keep coming back to them, keep going back to your triangles and unit circles and all that sort of stuff. So we've got k times, so negative cos of pi minus negative cos of 0. All that is still multiplied by k, and the right-hand side still just equals 1. Now, with cos of pi and cos of 0, we can go to the unit circle. There's our angle of 0, there's our angle of pi. Remember that we read cos from the x-axis. So cos of 0 is positive 1, cos of pi is negative 1. So we've got lots of negatives going on here. K times negative 1 minus negative 1. All right, so what's going on in that bracket here? Well, that's going to be positive 1 plus 1. So k times 2 equals 1. And therefore k equals a half. Okay, so we found this value of k. Now, the question didn't make us sketch this graph, but we kind of know sine graphs pretty well. And so we know that, normally, if it's a positive sine graph, it's going to start at the middle and go up. And so it certainly made sense that k had to be a positive number there, because remember, the other component of a probability density function is that it's got to be above the x-axis. So this first part from sort of 0 to pi makes sense that we need to have this area being above the x-axis. So that's what we're picturing when we think about this function. Okay, now we've got a couple of probabilities to find. So part B says find the probability that x is greater than pi on 6, but less than pi on 3. And so the way that we're going to do that is to integrate the function with pi on 6 as our lower terminal and pi on 3 as our upper terminal. So pi on 6, pi on 3. We now know that the function, because we know the value of k, we know the function is half sine x. Right, and now our job is just to evaluate this definite integral to find the probability. And it is a probability, so even though there's going to be lots and lots of steps to this, remember that the answer's got to be between 0 and 1, okay? Because all probabilities are between 0 and 1. They can be 0, they can be 1, but they can't be outside those values. All right, so we said before the antiderivative of sine x is negative cos x. I'm actually going to pull that 1/2 out the front before we start, because that'll just make life a little bit easier. So a half times negative cos x with our terminals. So this time we're going to have to use the triangles to work this out. Sorry, excuse me, just trying to find some spare paper to scribble on. All right, so the next step we're going to have to work out, cos of pi on 3, cos of pi on 6. So if you're a bit rusty on them, go to your triangle with pi on 3 and pi on 6 on it, pi on 6 in it. There's pi on 3, there's pi on 6. So we can use that to help us figure out cos of those two angles. Remember, cosines adjacent over hypotenuse. Okay, so when we go to evaluate this, half times negative cos of pi on 3, that's our upper terminal, minus negative cos of pi on 6. All right, so a half times our cos of pi on 3. Let's go back to our triangles. If that's our theta, then there's our adjacent, there's our hypotenuse. So cos of pi on 3 is a half, so this would be negative 1/2 minus negative, so plus cos of pi on 6. And so if pi on 6 is our angle, then the adjacent becomes root 3, and so cos of pi on 6 is root 3 on 2. So plus root 3 on 2. Okay, so now we can just expand by this half, and we've got our final answer. So the probability we can write as negative 1/4 plus root 3 on 4, or we could obviously bring those two together. I'm going to write it as root 3 minus 1 all over 4. Now, usually we say you don't have to manipulate your answer too much as long as you give a correct answer and it's simplified. That's as far as you need to go. But I would say in this case, it's good to write it that way because this is just a good check that we have actually got a number that's between 0 and 1. Okay, you don't have to like know off the top of your head what the square root of 3 is, but I know that the square root of 3 is it's bigger than 1, but it's less than 2. All right, so I've got a number here that's bigger than 1, but less than 2. So when I subtract 1 from it, you know, that becomes like 0 point something, and then divided by 4. Yeah, like I'm confident I know that that number is a positive number, but it's not bigger than 1. And that's important because it's a probability. So if you had something that looked like it was going to be a negative answer, you'd know, hang on a second, I've got to go back and check that working. Okay, this one here is a good chance to practice conditional probability. This one says find the probability that x is less than pi on 3, given that x is greater than pi on 6. So before you get too worried about what's going on there, I would always, with any conditional probability question, chuck it in the formula. Okay, so yes, we need to know how it's, like we need to know how to read this, I suppose, but sometimes you can get really tangled by trying to think about the question too deeply before just saying, well, the formula says for conditional probability is that I've got the probability of both of these things happening on top. So probability that x is less than pi on 3 and that x is greater than pi on 6 on top, divided by the probability of the condition, the probability of the thing that we know has happened on the bottom. Okay, now how we've written this on the top can probably be tidied up a little bit because we're really just saying that we want x to be greater than pi on 6 but less than pi on 3. In other words, we want x to be between pi on 6 and pi on 3. So I'm going to rewrite it as, the probability that pi on 6 is less than x and x is less than pi on 3 divided by the probability that x is greater than pi on 6. Now the nice thing about that is that this top probability was the one that we just worked out before, right? So we've kind of got part of that answer already worked out. What we just need to do is find the probability that x is greater than pi on 6. So in other words, we might write it like this. We might say, well, top number is, so equals root 3 minus 1 all over 4 divided by, or over, the probability that x is greater than pi on 6. And the probability that x is greater than pi on 6, we come back to our function, well, that's just going to be the antiderivative, or sorry, the integral from pi on 6 to essentially as big an x value as we can get. And in this function, the biggest x value where the function goes up to is x equals pi. So it's the integral of the function, and our function was a half sine x. The integral of the function from pi on 6 to pi. Okay, so this is the bit that we've got to work out because this is the probability that's going on the bottom. All right, so we know that the we can take this half out. Now, we've already kind of integrated the function once, right? So you can kind of go back to what you've already done. We're just using different terminals to what we had before. So you know that it's going to integrate to a half times negative cos of x. Our terminals here are pi and pi on 6. Clearly I'm going to run out of room here, so I'm going to need to grab some scrap paper again. Alright, so this will equal root 3 minus 1 all over 4 divided by, alright, so a half times negative cos of pi minus negative cos of pi on 6 half times, so negative cos of pi is actually negative negative 1 minus negative cos of 6 becomes plus root 3 on 2. We worked out cos of pi on 6 before, so again you can kind of go back, take some shortcuts. Like we in the previous one we did cos of pi on 6 to get the root 3 on 2, so we know that's there. And then it's just a matter of kind of tidying this up as best we can. So we've got half times 1 plus root 3 on 2, so that's going to be, I'm trying to, I shouldn't do too much at one go. Well actually, 1 plus root 3 on 2 is really 2 on 2 plus root 3 on 2. I'm making this a bit messier than I need to, but anyway. So half times that, well that's going to be, 2 plus root 3 all over 2. When we multiply that by half, it's actually going to be 2 plus root 3 all over 4. If we do the tip and times, we've got, root 3 minus 1 over 4 times 4 over 2 plus root 3. 4's cancelling out there. Sorry, I could have given you a nicer example to start this chapter off, didn't I? But let's leave it there. There's more fancy things we can do with that expression, but let's just leave that there as our answer there. Mainly just wanted to give you that sense of how this works in terms of calculating probabilities using integration. So hope that those examples haven't warped your mind too much. There is another one there. We might have to come back to that in another video because this one's pretty long. But what I would say is if you need a hand, if that's not making sense, if anything in there that you kind of want to go back over, then please make sure you reach out to your teacher and get in touch. All right, cheers everybody.